Okay, we are back. I'm recording. Am I recording? Yes. Okay, so we're looking at, we have 3 more methods in our line class, and they all involve 2 lines. So usually when you have, our class, when we create a new line, we'll create an instance of that class, an object, and then that object is like the first person object. So you have line 1, and then when it wants to call line 1 dot equals, it sends another line in as a parameter. So that's where we use this key. That's not a keyword, but we use the word other to represent not the line that, not the object that's calling, not the instance of the object that's calling the method, but the parameter that you're sending in that's another object of the same type. So that's very common, and we will just do that with any object. So you saw it with point, where I was checking if they're equal as point other, etc. Okay, now the distance between, it was distance between, and then we send in a point other as well. So equals is pretty straightforward. What's weird is, 2 lines would be equal if they actually have the same equation. So, we have to decide what makes 2 lines equal here. Is it if the 2 points are the same, or should we make them equal if the two points are the same, or if they're actually the same line? And I can't decide what to do. So I'm gonna first write it with these 2 line objects are the same if these 2 points are the same. So that in the idea there is that we're not really looking at the entire line, we're just looking at a line segment. That the naming of this as a line, I should probably then change it to a line segment, and then it really wouldn't have the same equation. So 6 in one, half dozen the other. So I'm going to first do it at they're equal if the 2 points are equal, and then we can talk about maybe in another separate video whether we should modify that or not, or at the end of this video. So again, we'll put that above the toString method. It's going to be a Boolean equals. It sends in a parameter of another line, so we call that other. Just to sort of get rid of this error message, let's return false. And above here, let's tell the user, or tell the programmer that 2 line objects are equal if they have the same point fields. We could also modify to allow for same line, different points. I'm trying to think if that is easier or harder, or if what that means for us here. But first, let's do it with the 2 point fields. Okay. So what we want to return is the value I need, the points of each field to be equal. So it would be here, we want to return, what do we want to happen? We want P1 to equal other dot P1. And actually, it's not equal like that. It's P1 dot equals. Because again, I don't want to just say, are they actually pointing to the same thing, or are they actually the same values? P1 dot equals get P1, other dot get P1. So you can see how the layers of this get a little confusing. So we want the first points to be equal, and P2 dot equals I need two ands. P2, I probably don't actually, it accepts one, but just for consistency. P2 dot equals other dot get P2. Like I have an extra parenthesis, but maybe not. Nope. I don't need this return false. So that's gonna, if they're equal, if they're both equal, it's gonna return true. If either one of them is false, it's gonna return false. So that should be working, and we can just check that. Well, we can check it in our client with, I want to keep all of these lines, all of this code for now. So I want to do a new bit of code here that just says system.out.println line 1 is line 2. And this should be false, right? Because they're not the same lines. So plus line 1, or we could also do line 2 dot equals line 1. They should both return the same thing. And that should be false in this case. Yep, false. Okay, good. And then maybe we put a print line below it. Okay, so then we want to check what happens when two lines are the same. So let's create, so I don't want to just create a line and say line 3 equals line 2, because that actually is the same pointer, and then they would be true because they're actually pointing at the same object. So what I want to do is I want to create a new line, and I think to be safe, I'm just going to create new points. So I'm going to say point P5 equals new point, and I'm going to just make it that, let's do it the same as line 1. So let's see, line 1 is now horizontal, line 2 is vertical. Let's do that up here. Let's see. I'll do that up here, and I'll compare it to this line 1. So I'm going to go 5, 8, and 6, 10. I'm going to move this code up in a few minutes. New point 5, 8. Point P6 equals new point. You can see, the client can very quickly, even though we're testing sort of, is equals, right? It's not a huge thing. And then we'll do line 3 equals new line, and I want to send in P5 and P6. It's not a lot of code that we wrote in the, oops, I have a space in there. I don't have that space. In the class, but then there's a lot of work sometimes in the client to check if the code in the class is behaving correctly. And as your client gets more and more complicated, that can be problematic. So technically, we should probably be checking. No, I don't have to check those things. I could probably get rid of all this code now because I don't need to check these other things. But let me leave this in here for now, and I want to put this line 3 above, right after this line 1 stuff. So I want to put it in right here, paste it in there, and then I want to check if line 1 equals line 3 right here. They should be equal. So I'm going to just do a print statement. And I want to print, is line, in quotes, line 1 equals line 3. And I'll do line 1 dot equals here. We'll send in line 3. Run it. So line 1 equals line 3, yes, true. and then we switch line 1 to horizontal, and we set up a vertical line, and line 1 does not equal line 2. And I'm going to put another print line statement. So I could, if you wanted to, you could put comments in here that say what you're testing, but I'm really kind of doing this for temporary, and then if I had to demonstrate all of the methods, I would kind of write a new client that sort of goes through them one by one in order, and then, or I could even copy and paste. I'm testing this client, copy and paste into my reflections report. I don't want to try to keep all this code going in general. And it's very syntactical, so none of this code is logically difficult in the client. So I mean, it doesn't hurt us. None of this was hard to type, right? Sometimes it feels like, oh, I'm losing so much if I delete it. But let's see what the next two methods are. Well, so I know I'm going to need. I want to be able to test these things on horizontal and vertical lines as well as non-horizontal vertical lines. So I know that I want to at least keep some of the various lines that I have in here. And so I'm going to leave all the code alone. Let's just run it one more time. But notice what I've done with my output is I've sort of still maintained my output. One thing I could get rid of is these printing of the lines at the end, because that's happening now up in the toString method. So that would clean it up a little bit, this find equation method that I'm calling in each of these I can get rid of. Because I'm now calling that from the toString method. And we'll run that and it'll just be a little cleaner. I could also get rid of the slope things, right? I don't really need that anymore either. So I can get rid of the print statements that talk about slope. Again, because I have the equation of the line and I know that the find slope method is working, so I don't need to keep checking it. And again, so now it's a cleaner output. Printing line 1, printing a horizontal line, printing a vertical line, and whether the lines are equal or not. And that's done. And then, so there's two more methods. I'm not sure. I'm not sure I want to keep going or take a break and do them. Well, let's do isParallel. I think it's pretty quick. Okay, so we'll put isParallel. I was just debating whether or not to try to modify equals to represent, whether you have the same line or you have different lines as mathematical objects as opposed to objects in Java. So there's a difference here. The object in Java has two fields and it's 2 points. Now, mathematically, that defines 2 points define a line. So so far, I have treated these lines as if they're really just this object with 2 points. At some point, we could switch to sort of say, okay, we actually want it to represent a line in 2 dimensions, which we've done a little bit of with finding the equation of the line, but I haven't done with regard to, like, nowhere have I checked that the points can't be equal, because that would not actually create a line, that would create a single point. So, that maybe I need to say that I've already checked that up here. So for right now, we're treating this as an object in Java, and that object is defined by these 2 points. So it's slightly different than what you would do mathematically with the line. Okay, so I'll keep with that still. In other words, when we do the method isParallel, we will say returns true if the two lines have the same slope. And then maybe underneath it, I can say something about here we are ignoring the case when two lines are the same. And it might be something that we come back to. So that little note that I'm putting in there is a note to sort of myself or the next coder or someone who's reading this later to sort of say, oh, we haven't really taken care of this. Let's go ahead and return false just so I don't have to see that error message. Okay, so two lines are equal if they have the same slope. So we can just return the value of slopes are doubles. So I think I have to use the, do I have to use the dot equals? We'll find out. Return, we want to call find slope. For this, the object that we're in, this object, and want to check if that equals other dot find slope. And we actually just want to return that value. If they're equal, that will return true. And they have this, then the lines are parallel. If they're not equal, then that will return false. Checking it in the client. So another thing to think about is this going to work for both vertical and horizontal lines? Well, if it's a vertical line, then that slope is NaN, and those are going to be equal if they're both vertical, so it should work. And if it's a horizontal line, the slopes will both be 0, and that should work. So when we get back to our client, what I want to do is I'll create a fourth line, and I will use that fourth line and I will manipulate its points for each of those cases. Is it parallel to line 1? Is it parallel to line 1 when it's horizontal? Is it parallel to line 2? Okay. So where do I want to do that? Let's create the line up on top. So P1, P2, there's line 1. Even above that, I'm just going to, right in here, going to go line, is it line 4? Line 4 equals new line, and then I'm going to cheat in here, and I'm going to go new point. So I want it to be parallel to line 1 to begin with. So I'm going to go slope 2. So I'm going to go 0, 5. And if I go 1 to the right, oh, and then I need a new point. So I didn't create these points. I'm just putting them in the syntax here. I want to go 1 to the right and up 2 so that it will be parallel to line 1. And then right below this line 1, I want to test it. So system.out.print line 1 to line 4. And this can just be a temporary print statement because I'm going to change line 4 around for each of the cases. So what am I printing? Is parallel, line 1 is parallel to line 4. So I'm going to just keep modifying this thing. I think I have a typo, parallel, P-A-R-A, 1R. No. Oh, I need a plus. There we go. Run it. So they should be true. It should be parallel right now. Is line 1 parallel to line 4? It says false. Line 1 and line 4. Let's check. So line 1 has slope 2, and line 4 also has slope 2. Uh-oh. Return. Oh, maybe it's this other dot find slope. Maybe it's no. Try that again. So I'm going to look in my client. Line 4 goes through 0, 5, and 1, 7. So it has slope 2. Line 1 also has slope 2. That should be true. So something's not working. So right below this print line statement, let's print line 4 out and just see what that looks like. Line 4 to string. And again, this is what happens is like when something's not working, so those slopes are equal, so this should be returning true. So why isn't it? I think it's because I declared these as an object, these doubles or something maybe. So maybe I need to say, instead of doing this dot find slope, I want to do find slope dot equals, and then in here I'm going to put others dot find slope. Because I made find slope an object return of capital D double, maybe the equals for the primitive double isn't working. I think it should have, but let's see what happens. Oh, you know what it is? It's the rounding, because a double is usually rounded. So when they do the division, one of the doubles, like at the end, has 0.2 and the other one has like a 0.7. And so they're not recognizing them as true. That's that where you have to look at the difference between the two. But the dot equals is doing that for us. So now it works. Or at least it works when they're parallel. So now I want to check if it works when they're not parallel. So now I'll change this to an 8 in line 4, and that should have slope 3. And so now they are not parallel. So that's working for non-vertical, non-horizontal lines. So now I want to take this code out of here. I can leave it there. And let's see. So line 3. No, there's a new line 1. Let's see what I do. Sorry. So line 1. And line 3 are the same right here. So I can, let's get rid of that. Let's get rid of this line 1 equals line 3. I don't think we need that. Do I use line 3 anywhere else? Nope. So I'm just going to get rid of this line 3 code here. And then sometimes when you do that, you create a bunch of errors because you're somewhere else below is depending on it, but I didn't. I want to now make line 4 parallel to the horizontal line 1. So that would mean it needs to have slope 0. So let's go through 0, 5, and 1, 5. And that will have slope 0. And then I will, so those are not going to be parallel, but I'm going to take this line of code here, copy it, and put it in down below after we made line 1 horizontal. And so it should first be false, and then it should be true. So line 1 parallel to line 4, false. And then line 1 parallel to line 4, true. Good. And then now we want to check it with against a vertical line. So I can take these print statements out of here. I don't need this anymore. Actually, I'll keep both those lines of code. I'm going to cut them out of there, and I'm going to paste them in on the bottom after line 2, the vertical line. I'm going to get rid of the testing for is equal. Get rid of that. And then I want to know if line 2 is parallel to line 4. So I'm going to do line 2 dot is parallel. And right now the answer should be no. They are not parallel. If I want them to be parallel, I would want their x values to be the same. So I'm going to go back to line 4 up here. Why don't, well, I need to, let's see, did I use it anywhere else? I was going to get rid of this code in here. Okay, and then line 4, I'm going to make it parallel to this vertical line. So let's go through 1, 5 is fine. Let's go through 1, 8. So the x values are the same. This is now a vertical line, and it should be parallel to the vertical to line 2 at the bottom. Yep, and it says true. So parallel lines are working. And now what's left is perpendicular. I think this is a good place to stop and come back and do perpendicular and maybe clean up some other things at the end to encapsulate it all. But we'll go back to our, you know, it's interesting. So that this code, this method was one line, literally returning a dot equals thing. And it, in the testing, took a lot longer than actually writing the code for the method. And it is something you want to be careful of, because we need to test all these different cases to see, if, again, if it's behaving as we expect it to behave. And we saw that it didn't initially, because of what I had done with find slope, returning an encapsulated double, it's thinking that even if the things stored in there are equal, they're two separate objects. Now I'm checking if the objects are equal by checking if their fields are equal, and it did work.